This presentation is about independent demand inventory management, although the techniques that we'll talk about in this presentation are also applicable to dependent demand inventory management. The first technique I'd like to talk about is inventory turnover. Inventory turnover is a type of return on asset measure. All businesses have assets. In general, we like to compute the return on assets in general for a business. In other words, what was the profitability of a business, and let's divide that by the asset base of the business, because if we can make the same amount of profits with less assets, or make more profits with the same amount of assets, that's a good thing. Inventory turnover is the same type of calculation. It's a flow, like the amount of money that we made for a particular time divided by a stock, such as our asset base, during the amount of time, except it's more particular to inventory. So instead of our overall return or our overall margin for a particular period of time, we're interested in the amount of inventory that we sold or that we consumed during a period of time, and we're interested in comparing that down in the denominator to our average inventory for the period of time. Sometimes we just use the ending inventory for the period of time because average inventory can be sometimes difficult to compute. Let's do an example. So let's say that during the year 2007, our cost of goods sold was $1.5 million, maybe for a particular business, maybe a particular small retailer or restaurant. And let's say our average inventory was $300,000. So our turnover would simply be 1 over the other, or 5 inventory turns per year. So it literally means our inventory turns over 5 times during the year. So if this was a retail situation and we quit ordering any new merchandise from our suppliers or from our warehouse, but we kept selling stuff, it would take 1/5 of a year on average for us to completely empty out our shelves. So if we think about this, what we want is big numbers. If we can do $1.5 million worth of business on a $200,000 inventory investment, we'd be even happier. On the other hand, if we can only do $100,000 worth of business on a $300,000 investment, we'd be a lot less happy. If I told you, hey, I'd like you to buy my store, my sales last year were $2 million, my cost of goods sold was $1.5 million, you really wouldn't know whether that's a good deal or that's not a good deal, because you'd want to know, well, what inventory investment does it take to do that level of business? If I told you it took $300,000 worth of inventory investment, you might say, well, okay, that's not so bad. If I told you it takes a $2 million inventory investment, you probably wouldn't want to buy my business. So again, this is kind of a subset of return on assets concept. So the computation that we just talked about works pretty well if we're interested in understanding inventory turnover on an aggregate basis, for an entire business. But a lot of times in operations management and supply chain management, we're interested in a more granular view of the world. We might be interested in what inventory turnover was for a particular part or a particular item or a particular family of items, or for a set of items that's managed by one particular inventory manager, because we're interested in understanding, is this inventory manager performing, is he or she performing as well as other inventory managers in the company, or we might be interested in ascertaining the inventory turnover of a particular location, such as a particular distribution center, and comparing that to other distribution centers in our company to see who's doing a good job, who's meeting our performance criteria, and who's not. Well, again, for those situations, we can't really compute a cost of goods sold. So what we do is we look at the actual inventory levels in the numerator. The concept in the denominator really doesn't change. In the numerator, we look at the beginning inventory. We add in what we purchased during the period that we're interested in, and we subtract out the ending inventory. Just like before, we can divide that by the average inventory for a period if we know it, or we could just arbitrarily pick our ending inventory level or any other inventory level at any other point in time and just kind of arbitrarily assume that that's representative of our average inventory level. So let's look at an example of this way of calculating inventory turnover. So here's a manufacturing example. Let's say that this is a particular part that we use in the product that we make, and we're going to calculate inventory turnover this time down at this part level, and just to make life even a little bit more interesting, we're going to do the calculation just for a month. So let's say that we started out the month with 20,000 units of this material in stock. We ended the month with 15,000, and during the month we bought 75,000 units of this material. So we started with 20,000, we bought another 75,000, but we ended up with 15,000. So that's our numerator, the beginning inventory plus the purchases minus the ending inventory. And in this case, we're just going to use the ending inventory and assume that that's representative of the average inventory for the period. So if we divide the numerator by the denominator, we can see that we got 5.33 turns. Now it's important to understand that inventory turnover is always calculated for a particular period of time. So this was 5.33 turns during February. We typically annualize these numbers. So to annualize a monthly number, we just multiply it by 12. So if we do that, we'll see that that works out to 64 turns for the year. Inventory turnover is a pretty powerful performance measure. Usually if a company is getting good inventory turnover, or a facility or an individual manager is getting good inventory turnover, they're probably doing a lot of things right. Again, this is a basic kind of measure of how well I'm managing an asset. Inventory is a hugely important asset for many different types of businesses. One reason that we're interested in how good of a job we do managing inventory is that it costs us money to carry inventory. This slide kind of sums up some of the costs of carrying inventory. Capital costs reflect the idea that inventory is an investment. Inventory is an asset class. If I invest $200,000 in an inventory of a particular family of products that I'm going to sell in my store, that's money that I can't spend doing something else, like maybe investing in the stock market or investing in some other business or some other area of my business. So the return that I could get in those other areas is the capital cost, the opportunity cost, and that's generally one component of holding cost. If I can get 8% in the stock market, my capital cost, my opportunity cost would be 8%. Different businesses will use different figures for that. It also costs me money to store inventory. I need to put it in a warehouse. I may own the warehouse, I may lease the warehouse, but either way, those types of costs that are associated with storing inventory are real costs that I incur. There's also risk costs, and a lot of times when we talk about risk, we're talking about expected values, but here we're not exactly talking about that. Examples of risk costs would be things like theft, damage, obsolescence, that tend to happen to material when it's in inventory. So it may be the case that for every $1,000 worth of material that I have in inventory, I lose $1 of that material due to theft. Well, that's an important risk cost. It may be that I lose on average $2 of that $1,000 every year because the inventory went bad or went obsolete. Those would also be examples of risk costs. EOQ, economic order quantity, is something that we'll talk a little bit about later. If we're doing EOQ calculations, then we're only interested in the variable portion of storage costs, but if we're interested in doing other types of inventory holding cost computations, we may use the fixed portion of storage costs as well and prorate that somehow. So my inventory carrying cost is the dollar value of the inventory that's held for a period times the holding cost for the period. So to start out with an example that's fairly straightforward, if I had 100,000 radios in inventory on average during the year, maybe worldwide, and each one of those radios costs $10, and our company uses a 15% annual holding cost for inventory, then the holding cost for those radios would be the number of radios times the cost per radio times that holding cost figure, which would be 1.5 million. So it cost me 1.5 million to maintain that inventory of radios. Sometimes we're interested in understanding inventory carrying costs for just a shorter period of time. For example, if during a 2-week period I was holding 1,000 radios in inventory, maybe it's some special inventory that I built up just for a special period of time for some type of promotion or something like that. What would be the cost of doing that just for 2 weeks? And let's assume this time that our company uses a 12% annual holding cost. Well, I'm talking about a 2-week period here. I'm talking about 1,000 radios times $10, so $10,000 worth of radios, but only for 2 weeks. So what does it cost me to carry inventory for 12 weeks? Well, I can take this 12% and divide that, or figure out what that is on a weekly basis. And to do that, I just take 12% and divide it by 52. But remember, I'm talking about 2 weeks, so I need to multiply by 2. And if you multiply all that together, you'll see that that comes out to $46. Again, this number in blue here is my percentage cost for 2 weeks. One reason that we're often interested in understanding inventory carrying costs for shorter periods of time is for transportation inventories. I can figure out my average transportation inventory using a formula that's in the book, and that prevents me from having to then figure out what my my weekly or daily carrying cost is. The way I figure out my average transportation inventory is I take my transit time times my annual demand and then divide that by the number of days in the year, and that's going to tell me what my transit inventory was on average. Let's look at an example. If my annual demand for a particular material is 2 million units and my transit time is 14 days, then my average transit inventory is roughly 76,000 units. That means on average, this is how many units of this material I had in my transportation pipeline. That might be on a container ship, plus stuff that I had on rail, plus stuff that I had in trucks, all that stuff together. On average, I have about 76,000 units that I own that's in transit at any given time. Now, chances are, because we transport things in large lot sizes, that it's not 76,000 units all the time. It's probably a lot more than that when I have material in transit, and then at other times I may not have any material in transit. But again, on average, it's about 76,000 units. So what does that cost me? Well, if the units cost $2 each and I have a holding cost of 20%, then we just use the same formula that we used before. That's 76,000 units at $2 a unit. It's about $140,000 worth of stuff, and if my annual carrying cost is 20%, then it costs me about $30,000 to carry that inventory. Again, the 76,000 units is the amount of units that I have on average in transit at any given time. So this might be useful if we're thinking about maybe changing the mode of transportation. Maybe I can go with a different mode of transportation that only takes 7 days instead of 14 days. Well, that's going to cut this 76,000 in half down to about 18,000, and that's going to cut this number in half down to about 15,000. So if I can get my 7-day reduction in transit time for less than $15,000, then that's probably worth doing. If it's going to cost me more than $15,000, well, it's probably a bad deal because it's only going to save me about $15,000. So far we've been talking about understanding inventory costs. ABC analysis is a little bit different. ABC analysis is a tool that can help us manage our inventory better. And oftentimes if companies are getting poor inventory performance or they have excessive inventory carrying costs, one thing that can help them is to start doing ABC analysis on their inventory. ABC analysis, as we'll see, is based on the Pareto principle. Usually if we do a good job managing the few critical items in our inventory, we don't have to do such a great job managing a lot of the other items, yet we'll still get fairly high inventory turnover. So let's talk a little bit about how this works. ABC analysis is a material classification system where we classify each item by the dollar volume of usage. So the number of each particular item that we use times the cost of the item that we use gives us the dollar volume of each item that we use. As I mentioned before, usually a small percentage of our items, 20% of our items or less, is going to account for a huge percentage of our total volume. So if we can do a good job on those 20%, our overall inventory turnover will be pretty good. So the A items tend to receive the most, or should receive the most intense control. The B items are less important, and then the C items are not nearly as important, so they don't need to be controlled and managed nearly as intensively. So let's look at an example. Let's say you manage a service parts inventory. You're responsible for ordering parts from different vendors, and your goal is to keep inventory and service levels inventory low and service levels high. You know how much of each inventory item you use on average from looking at historical information, and you know the cost of each item. So if we have that information, we can do an ABC analysis and figure out what our A items are, and that'll tell us which of the items we need to manage the most carefully in order to maximize our inventory turnover. So here's an example of our inventory. Let's say we have 10 items in our inventory. This is an artificially simple example. If you just had 10 items, you could manage them all with equal intensity, but we don't want the computations to get too out of hand. Here's our annual usage. So for example, we use 2,000 units of item 21 every year. Again, this could be based on a forecast. It could be based on historical analysis. Each one of those units of item 21 costs us $55 a piece, and you can see we've got unit cost information for each of the other items. So these are the inputs to the problem. What we've got to do is we've got to figure out the dollar volume for each one of these units, and again, the dollar volume is the annual usage times the cost. So for item 21, the dollar volume would be 2,000 times 55, or $110,000. After we've figured out the dollar volume for each one of our items, we then convert that to a percentage. And of course, to do that, you take the dollar volume for the particular item and you divide it by the total dollar volume. So for item 21, it would be $110,000 divided by $1,676,000, and that's 6.6% of our total dollars. So we spend 6.6% of our total dollars on item 21. Now we go to the next step, which is just simply sorting these items or ranking these items based on dollar volume. And I've done that here. You can see that item number 407 with 42% of my total dollar volume is my highest ranking item. Now what I need to do is assign an ABC code to each one of these items. The items with the highest dollar volume are my A items. So between item 407 and item 210, I've got just a little bit over 80% of my total dollar volume. So I'm going to say that those are my A items. Again, that accounts for 80% of my total dollar volume, even though it's just about 20% or 2 out of 10 of my items. My next 10% of dollars generally I'll call my B items. So here in our example, roughly that's item 21 and 388, my next two items. And then the rest of the items, which only account for my remaining 10% of my dollars, are going to be my C items. I'm going to label those my C items. And you can see that's a pretty big chunk of my total items. So again, if I do a good job managing those A items, managing those first two items, I'm probably going to have pretty good turnover. I don't need to manage the C items nearly as intensively, so I may only check inventory on the C items maybe once a month and order those items once a month. On the other hand, I might take inventory of my A items twice a week and try to order those items twice a week in order to keep my inventory levels down a little bit more low and watch those items a lot more closely.